Engineering Newswire, we're using X-ray vision, augmenting humans at Lockheed Martin, working in wastewater, and licking digital lollipops to taste turkey text messages. Gobble gobble.
Why eat turkey tomorrow when you can cut calories using a tongue interface? Tongue interface. Not exactly a phrase you would associate with a family gathering. Using electronic simulation of taste sensations, researchers at the National University of Singapore are now simulating primary taste sensations using electrical and thermal stimulation of the human tongue. That's right, you place an electrode on your tongue and it can mimic sweet, salty, bitter, and sour sensations. Kind of reminds me of licking a battery or chewing on foil. The sum of metal and mouth has never been a positive experience for me. Well, except for... The digital taste interface consists of two primary modules. The control system, which formulates the electrical and thermal stimuli that communicate with the tongue interface. Really just two pieces of metal that you wear on your tongue with a Peltier module and a heat sink. By adjusting the magnitude of current, frequency, and temperature change, the system has had initial successes simulating sour and salty sensations. Just look at her, she's having a good time. The team now has plans to develop TOIP, or Taste over IP, which could lead to taste messaging via digital lollipops. Think of the possibilities. Missing out on grandma's turkey this year? Just have her ping your tongue ring using Taste XML, the remote procedure calling protocol currently in development. What's that? Canned cranberry sauce. Come on, Grandma. A little effort. Nah, I was just kidding. I love your cooking, Grandma.
Needles. They creep me out, make me nauseous. But I've been blessed with good veins, so it's not difficult for nurses to be quick with the prick. Some people aren't so lucky and end up getting stuck several times. Like this guy.
Stop, it's gonna hurt if you move.
Hold still. Don't move.
A breakthrough medical technology from Evena Medical helps to avoid these poking problems by enabling nurses to see through a patient's skin to the vasculature beneath. Using Evena's eyes-on glasses, even hard-to-locate veins are easy to see and access. These unique eyes-on glasses feature a multispectral imaging patented technology, real-time anatomically accurate images, an EMR PACS interface that enables automated, improved, and more precise documentation of appropriate care, hands-free, cart-free, wearable technology that allows medical staff to maneuver anywhere, anytime with the complete vasculature image right before their eyes, and see-through eyes-on technology, which allows the user to have full situational awareness to keep eye contact with the patient, plus a clear view of the patient's area of interest, enabling quick and easy location and access to the best vein. According to Evena, the glasses seamlessly blend the physical and digital worlds, introducing a new world of applications possible for commercial enterprises and consumers alike.
Let's hope there isn't a digital lollipop for this one, because Cambrian Innovation is commercializing environmental solutions based on newly discovered electrically active microbes. The company was spun out of MIT in 2006, and since then they've been working to harness bioelectricity and advances in electrochemistry to help clients in industrial, agricultural, and government sectors recover clean water and energy from wastewater streams. Somewhere in there is a pun about odious revenue streams. I don't know. Backed by the National Science Foundation, engineers and co-founders Matt Silver and Justin Buck are bringing their research from the lab to the market in the form of EcoVolt. EcoVolt leverages a new process for producing methane dubbed electromethanogenesis. Electromethanogenesis. Worth 34 points on Words with Friends if you can pull that one off, Joy. The EcoVolt system sends wastewater through a bioelectrochemical reactor. As water filters through it, special bacteria eat the organic waste and release electrons as a byproduct. Those electrons travel through a circuit to generate methane, or CH4. A wireless signal remotely monitors the process, and the methane is piped out to an engine. It's burned with a small amount of natural gas to generate heat and energy. Just doing amazing things with fecal matter these days.
Lockheed Martin has decided to accept DARPA's Robotics Challenge. And when Lockheed accepts a challenge, well... In case you didn't know, the DARPA Robotics Challenge is a competition that aims to develop semi-autonomous ground robots that can do complex tasks in dangerous, degraded, human-engineered environments. Meaning, developers and engineers get money for making something cool. Shouldn't the world always work like that? Lockheed Martin has spearheaded the controlled autonomy hybrid approach in hopes of making humans more efficient and effective in dangerous environments, with their version of the Atlas robot. In this system, the robot isn't fully teleoperated, nor is it fully autonomous. Things like balance are functions that would be incredibly difficult, if not impossible, for a controller to command. So the humanoid robot does that by itself, while the controller can give the robot a little direction when it needs it. Lockheed's approach can be applied to several different autonomous systems, from drones to search and rescue robots, but the team takes pride in their humanoid platform. And who wouldn't? Look at this thing. It's just awesome.
Do you have story ideas? Comment below and we'll cover them in the next episode. For the PD&D channel, I'm Megan Zimba, and this has been your Engineering Newswire.